Good afternoon and happy Saturday, everyone. Joining us today is Joel Holland, NETA 4, NICET 4 in infrared thermographer level 2, who has worked for many of the major players in the electrical industry, including ABM, PowerCore, Eaton, GE, Reza, and now Shermco. While we find quite a few NETA 4s in the field, rarely have I run across someone holding both the NETA and NICET level 4 certifications. Joel is also one of the few voices out there that is putting out outstanding content surrounding the day-to-day life of a testing technician via his YouTube channel, Testing Tech Tips, which I found to be full of very useful insights and knowledge. For anyone working as or aspiring to work as a testing technician, you should definitely give Joel's channel a follow. Joel, thanks so much for taking the time out of your busy schedule to chat with us. Can you tell the audience a bit more about your background?
Well, thanks, Micah, for the shout out. And yes, it's a bit less of a cohesive background and more of a just ridiculous patchwork of random experience. I've had hiring managers straight up tell me they don't believe I've done all of the things that I've done over the last 10 or 11 years. And it's really just because I bounced from job to job, which is really unfortunate. I'm trying to put an end to that. Anyway, background. After tech school, I started out doing relay testing and retrofits for a couple power plants, just jumping right off the boat in with the sharks. After that, bounced around to a couple other testing companies, mostly worked on substations, did a lot of relays, a lot of relay retrofits, things like that, some general NETA testing, breaker work. And then, in 2020, I got recruited to help run a startup, or the testing department at a startup, which was just an absolutely incredible opportunity, hitting the learning curve smack on with the management responsibilities, hiring people. It's a mess. You're in recruiting, you know. Unfortunately, it was out on the East Coast. So just this month, I started a corporate sales gig with Shermco, and I absolutely love it here.
Very cool.
So that's what happens. You get your NETA 4 and then almost immediately get plucked out of the field and do something completely unrelated, but is what it is. I still have complete imposter syndrome because I feel entirely unqualified for my actual job. But then I felt this way my whole career. So just keep my nose to the grindstone. Right? Yeah, it's crazy. So just keeping my nose to the grindstone and trying to brute force my way into succeeding in this role too. And we'll see how it goes.
Awesome, man. I love it. And you definitely got some really, really cool experiences. And that's one of those things that really drew me to you and prompted me to reach out to you, because it is just a very, very broad. And I think what you touch on there in the intro as well is there are so many aspects of being a testing technician. You can be a relay tech, you can be a number of any different things out there. And it sounds like you've gotten a little bit of diversification from that aspect of things. So that is awesome. And like I mentioned, I've enjoyed the heck out of your content. What drove you to start producing that?
I've been in a couple different leadership roles at way too many testing companies. But I've seen sort of the same deficiencies over and over again, like the same lack of training everywhere I went. Not that every company doesn't do training, but I saw the same sort of holes in the knowledge base at several different places. And so I sort of want to highlight where people just sort of have that general lack of knowledge and make YouTube videos about it. So everybody can, everyone in this industry has access to that knowledge, or they can patch little gaps in their background. Having something tying the theory and the math to the real world, how you actually put the rubber on the road, that is something that even good training programs sometimes lack. So what I've really wanted to do is sort of give guys the experience of having a mentor out in the field for a specific task, where they can just watch over the shoulder like you would as if you were the new guy on the crew watching an experienced guy do it. I want to give people that experience.
And that is awesome. And I can tell you, I've literally devoured every piece of content you put out there, because, just in order to be a decent recruiter, you need to understand what the heck you're recruiting for. Right. And one of the things that was really, really impressive to me was your time delay curve video, and actually breaking down the way those work. And as far as relay time delays, they look very complex on the surface level, but the way you walked everybody, just walked us through it in the video made it was like an aha moment for me. And I've had several of those, and looking at your molded case breaker videos and things like that, just truly awesome stuff. So not a technician here, but I'm starting to work towards that. And
Sure.
Your content is definitely awesome from that aspect of it.
Well, thank you. It's just going to keep improving as I actually figure out how to edit videos and stuff like that.
We're both living that dream over here, man. And then, so your video on NETA and NICET was absolutely phenomenal as well. And Tom Wire and I had done one on it that wasn't nearly as in depth as the one that you did. For two different audiences. Ours was more of a general summation, but you did a very, very thorough deep dive on that. And like I said, it was phenomenal. Spoiler alert for the audience: the NICET accreditation process does have some work to do. I won't do a spoiler any further than that on Joel's videos there. But do you have any recommendations to navigate the process for those folks on the NICET side of the house more efficiently?
Well, obviously the long-winded answer is in my
Loaded
30-minute long video, but no, it definitely needs some improvement. Number one, I would say is be very, very careful with how you fill out the paperwork. Like their work history form is very particular. 100% of the requirements need to be checked off, whether you've done them or not. You really need to make sure that like all the paperwork is perfectly in order. 100% of your claimed work history in the field needs to be listed as electrical power testing. They'll reject your years of experience if you say you did anything even related to it, like PLC work or substation automation. It's bizarre. So like to me, that makes guys a better technician. Like that would make you more well-rounded. You understand how the system works. Yeah. To NICET, you haven't done enough testing if that's your background. So it was a little bizarre to me. And then number two, the biggest mistake guys who've complained to me about is that you need to have your like recommendation letter and your work history verification form completed by very specific people. I'm talking about this in the video. Like you need to have for your level 4, you need to have a PE fill out your form. I don't necessarily have one to sign off on all of the work that I've done.
Just a PE in your back pocket, right?
I'm like, I was able to make it work. I was able to find someone who was like, oh yeah, no, you do good work, and but it wasn't a smooth process. And if you have the patience for it, it's not that bad, but it's a lot of back and forth, and it's way more effort than it needs to be.
I feel that, and you can kind of see it. Like I said, we're in the in LinkedIn and on various platforms trying to find people all the time. And when we enter a Boolean search string that's related around NICET, there's just not many of those folks. And to me, the logical conclusion is the process is too hard, perhaps. Like I said, it's not my show to run, but sure. Or it's more complex, perhaps, than it should be. If that makes sense. I think
there's not as much of a market for it. Right, because NETA is a requirement. If you work for a NETA company, you're pretty much required to become a NETA technician. NICET is targeting like either small third parties or OEMs, right? So the OEMs don't necessarily need it. If you need to be a NETA or NICET to come on my job site. Okay, we're Eaton. I don't care. Have your breakers. I don't care what you do with them. So yeah, it's definitely a smaller market.
Gotcha. And that also makes sense for why there's not as many. It's just, it is mind-boggling because, you think you're doing something unique and it's like, all right, I'm going to go find the NICET bubbas that can actually fit in over here. And then you start your search and there's just not many of them. Or they're one of the other NICET programs like fire sprinkler alarms or something along those lines, So
right. And I
definitely not as many of the EPT types.
I think those other programs are a little bit better. They're more thoroughly baked than the EPT program. The EPT program seems like kind of an afterthought for NICET.
It's kind of what it feels like. Yeah, definitely on that aspect of it. Too dang funny. Now, having a broad array of experience, what do you find that technicians struggle most with understanding? And what would you say is the most challenging equipment out there to test and troubleshoot?
That's harder to answer than you might think, because everyone in this industry comes from a different background. So I came right out of tech school. This was sort of the focus of my program there. We've got, military veterans, IT guys, construction workers, engineering graduates, and we're all out there sweating in the sun at the same substation outage. So a really diverse crew is an insanely powerful tool, right? Because you can capitalize on everyone's different strengths. So yeah, you've got people that aren't very good with computers. You've got people that aren't very good, working with their hands, tearing switchgear apart. But if I had to pick one thing that guys really frequently struggle with just across the board, it's the software, believe it or not. There's so much of it, especially working for a third-party testing company. Like, you're expected to show up day one and be an expert, just instantly on site every time, no matter what the equipment is. You got to know what the equipment's supposed to do, how it's supposed to work, all the specifics about it. And you've never seen it before. And it runs on these annoying proprietary pieces of software. Every single manufacturer has their own. There's so much of it, and some of them are much less user-friendly than others. And there's not really a workaround for that. Like, my only recommendation is like, hey, I know I'm going to go work on this project and they got GE blah, blah, blah. Well, I'm going to get the software ahead of time and at least like pick through it, make sure that I know how to download the settings and, do all the steps that I need to do ahead of time. But yeah, it's rough. Every new project, every new piece of equipment, every new software, it's really rough.
And it seems like they're updating the software every year as well, almost, right? So are they changing the GUI on those and kind of like, going into various sub pages? And I've specifically heard that with regards to like the relay testing, like it can be buried 3 pages deep in the GUI, and it could be that one setting that can be jacked up that throws off all your results coming out the backside. Is that kind of your experience as well?
Yeah. And like, to piggyback off your other question, like the worst thing to troubleshoot for that exact reason, anything with like PLC logic or integrated relay controls, it's just a black hole when you're trying to figure out like why a pump doesn't run or why a breaker doesn't close. Even if it's set up correctly and wired right, and you've checked your fuses and you got the right inputs, it might just not be programmed right, or it might be programmed right in this chunk and it's different in this chunk. So,
but not in that one.
It's, and then in the fog of war, when you're troubleshooting a breaker, the weird crappy code somewhere else in the system might be hiding the real problem. So I love those projects because I'm a huge nerd, but yeah, they're really frustrating, and they can set you back quite a bit of time.
Well, and it's one of those, you can't just look at a one-line diagram and say, okay, it's broken up to this point, right? Because now you're dealing with like all the logic, all the NAND functionality and everything that comes in the ladder logic. It's crazy. But like you said, so I imagine that adds extra steps and difficulty rather than just your typical, hey, I'm following the 1-line or 3-line diagram to try to locate this piece of gear that's not functioning or give me the proper output. Sure. And half the time we show up to a site and they don't have 1-lines, or their 1-lines, like the recent version of their 1-lines from 1965. I'm like, okay, well, I know that relay wasn't around 1965. So where's the drawing for that? And you just get a blank stare. Like, why do you need drawings? Just figure it out. That's a skill unto itself. You can't teach that. You got to just be able to look at a panel and figure out where the wires go. Like, it's rough. So yeah, shout out to all my relay guys out there. Everyone troubleshooting control systems. It sucks, man. And that's one that I like. That's pretty much a de facto answer. I really like the point that you point out the software, because there are so many freaking varieties out there. You could have RTS and a serve and all these other things, or it could be the Doble product, or the different ones out there. So sure, totally understand on that. Even if you run the same test set. So I when I test relays, I use the Doble, F6150, and Protection Suite. I'm really, really good with Protection Suite. One of my best relay guys that I worked with at ABM, he runs the Doble F6150 and RTS, and we can't share test plans at all. So it's awful. And so well, this is kind of like, this is a little bit off our question set here. Is there no like standardized code? Like the NEC doesn't regulate, all that's still kind of free market driven. So there's no compliance standard in place to make sure that the outputs would be anywhere near the same. So, I mean, if you read through the NETA book, actually the NETA standards for relay testing are bizarre, because it's here's how you do it for electromechanicals, and then for everything else, it's modern relays, just do the same test. That doesn't work. Like, they're physically different. They operate in totally different ways. So there's definitely a need for improvement, in my opinion, for the standardization. But no, as far as how the software works, up until I would say like the really new stuff, the more
integrated substations that are run on IEEE 62850, that's very well standardized. They have to do this, you have to do this, you have to do this. I'm not an expert on it, there's too much. But no, for older relays, it's like, oh yeah, you need to test it, it needs to work, but then it's up to the end user or up to the technician to actually like figure that out. And that's
make
one of the
it
big
work.
Things. Yeah, like how do I make it work? Is it okay if I just like trigger the output? Well, sometimes yes, but sometimes no. So honestly, that's a big push for why I'm making on my YouTube channel, I'm making a whole series of relay testing videos. And like I can't even promise that like, hey, this is the right way to do it for your application, but like for most applications, for what I've done in the past, here's how I've done it. So you have at least some, you know, basis of this is how we get the protection functions actually operate, and when you would do one test macro over another and things like that.
No, it totally makes sense. And like you said, there's always 1,000 ways to skin to skin the cat on that kind of stuff. And it was the same way. Like I said, I'm not a NETA guy, and I haven't done any relay work, but like it's the same functionality and troubleshooting skills come to to be needed even in the military side of things, and trying to track down the various functionalities and like tracing down gremlins and ghost faults in a system and things like that. And even then, and I feel like the military does a good job of standardizing a lot of that stuff, but like it just seems like there's definitely it could be improved, I guess. Absolutely. Without being too critical of anybody's stuff.
No, absolutely.
Now, outside of the NETA maintenance testing standards and the acceptance testing standards, do you have any other go-to educational sources that you kind of lean into for improving your wisdom, I guess you could say?
Yeah, so in this industry, you definitely have to get creative to learn new skills and to figure out the right way to do things. There's no single unified handbook for all of the things you have to know, right? There's just too much stuff out there. So my best resource has always been other guys in the industry. If you have a mentor you work with, just soak up everything you can from that dude. If you've got like a new guy that's good with computers, have him show you how to do stuff in Excel, have him show you how to make test plans, stuff like that. If you have other friends at other testing companies, say I've got a guy that's really good with transformers. I call him all the time when I have a transformer question, right? And I've got people that call me with relay questions. So your Rolodex is really your best your best source of education and filling the gaps. So again, that's a really hard thing to sort of grow when you're new at the industry. You don't have all those connections. You don't have all the, million people in your phone. Oh, I have this one quirky little portable substation question. It's a question very specific to portable substations. Well, I know a guy who built portable substations, so I'm just going to call my guy.
Let me call that guy.
Right. Nobody has all of those resources when you start out. And even 10 years in the industry, I find myself lacking for help sometimes. But that,
and I could definitely see that. And one of the other things that kind of comes to bear, I didn't mean to cut you off, my bad on that one. But what comes to bear is like, you're also dealing with the billable hours and things like that. So if you're on site, let's say you are that junior technician and you're out there, well, the company's still worried about their bottom line and getting everything done in a timely fashion. So perhaps during that time crunch, it may even be difficult to get that kind of information. And then, and I think that's probably one of the reasons we're kind of seeing what we see, where it is literally robbing Peter to pay Paul with NETA 3s and 4s right now. You know what I mean? Because a lot of that wisdom that you have in the space, like you said, you know a guy that built portable substations. So what happens when that guy retires? There's got to be somebody that kind of comes in to fill that void as well. And hopefully. It seems like we have less people coming. Yeah, exactly. That's what's kind of crazy right now. It's a hopefully situation. And I don't know the answer to fix that, but I think what you just mentioned is like, you can't standardize that. You can't standardize, I'm going to call Drew or I'm going to call somebody else for something. It's a byproduct of getting the experience that's necessary to kind of move that stuff forward, in my humble opinion anyway.
Right. And then you look at the career path of these a lot of guys, they get their NETA 3, they get their NETA 4, and now they're project managers. Now they're managers. Now they're operations managers. Now they go into sales. The knowledge hasn't just disappeared, but it's moved out of the field. So there's no more opportunity to like have those, times when you get to share that tribal knowledge, you get to share that tip and that trick to speed your job up. So that sort of thing is really unfortunate. But like I said, I'm always I'm open. All of my friends know they can call me whenever. You got a problem pulling an oil sample, go ahead and call me. Like let's get it figured out. And I think that's really important for this industry, just having open lines of communication from the old guys or the more experienced guys and everyone else. Short of that, to circle back to your question, especially with relay testing, especially with breaker testing, stuff that's kind of formulaic, the only other like real source of that insider knowledge, believe it or not, it's in the manual. We have a saying, RTFM, read the effing manual. I tell so many people, like, you're just being lazy, not reading the effing manual.
Right.
Yeah, generally go straight to the manufacturer, download the manual for the thing that you're working on, whether it's SEL or Eaton or Schneider or whatever. They actually put a ton of effort into their O&M manuals, and they'll have sometimes like specific testing procedures that you need to follow or you're going to screw something up. A really good example, I think they're Schneider, I forget which one it is. They've got trip units, very specific. They track the wear of the breaker contacts. If you primary inject them too hot, your trip unit just says, hey, you worn through 70% of the life of this breaker and you've never put it in service yet. So there's things like that that are just hidden in the manuals that you have to know to do your job.
Right.
People don't spend enough time actually like reading the literature. So that's 1 and 2. It's always like get the tribal knowledge from someone who's done it before. Because if someone tells you, hey, like don't primary inject that breaker because it's gonna kill it,
right?
That makes it way easier than spending an hour reading the manual. But if you don't have that guy,
exactly,
RTFM, that's my go-to. I read so many manuals. 80% of my career has been reading manuals.
Well, and I mean, that's the only way you're actually, I mean, the manufacturers, like you said, they put a lot of time and effort into making sure that's right. And I know that's where the time delay curves and everything are in there. Like if you're not in the manual getting that stuff, and it seems like those are pretty much readily available via PDF, like on any of the manufacturers' websites. Is that
most
true?
Of the time? Yeah. Like I definitely run into issues with breakers a lot of times, especially like small breakers for small industrial commercial applications. The trip unit has to match with like a specific breaker, and there's like a different manual for this trip unit and this breaker and this trip unit and this other breaker and then this breaker with this other trip unit. And so sometimes finding those, like Eaton doesn't really do a very good job of making them obvious which one you need, or like the trip curves are different for different applications of the same trip unit. Stuff like that drives me absolutely bananas. That's something that I think the OEMs could be better about, just making them easier to find. Some are better than others. SEL, gorgeous. I love going to SEL for manuals. Their manuals are so good. They tell you how to do everything you need to do.
Awesome.
Yeah.
So how much overlap? So RTFM, got it. But like, how much of that kind of ties in with the ATS? I guess is more of a standards device, a how-to guide. Is that accurate?
Right. So one way to think about it is the NETA ATS or the MTS is sort of, here's what you need to do, and then it's up to you to either know how to do it or RTFM and figure out how to do it that way.
Gotcha.
A lot of this stuff, and even if you had the time to read every single manual, it would just take you forever. That's where a lot of it it's so much OJT, so much having a mentor helping you out, showing you how to do things, someone that can answer questions when you get stuck. There are things that aren't in the manuals, and I have found on not one but two occasions where manuals for like relays have been wrong. They're just objectively incorrect.
Wow.
So there are definitely things that you're not going to be able to, and past that, right? So you don't have an expert that you can call, and you don't have a good manual, or the manual you have is out of date, you can't find anyone. You can always call the manufacturer. Like they for the most part, they want their stuff to work correctly. They want you to be able to like use their stuff and continue buying their product, right? So I would say for the most part, they're pretty good. It's a time-consuming process, but for the most part, they're good. Usually.
No, that makes a lot of sense. And like I said, the cool thing is though, is after doing the cool thing is after talking to you, talking to, everybody else that we've had conversation with, it seems like there are tons of people out there that are willing to share their knowledge. This isn't some, corporate secret cloaked in secrecy. It does truly feel like most of the technicians in this industry are out there to help one another. And that is definitely a unique, you're not going to see that in corporate where it's, dog eat dog type stuff. So definitely a high point there. And like you said, I think that's the only way you can continue carrying on the legacy of wisdom and knowledge that comes from all those senior folks, is having those folks that are willing to do it. So yeah, man, at least there's that aspect of it where people are out there, willing to help each other.
Right. And when it comes to technical stuff, I mean, most of the people, honestly, they do it as sort of a brag, like, oh man, I'm so smart, all these people call me for help. It's great. It's great. I brag about that all you want. Please keep doing it.
Right. Yeah. I don't care for whatever the reasons that you do it for. If it's to float your ego, then float away.
Great. Great. You're the best. Keep doing it.
Yep. Just keep feeding me the information.
Yep.
Now, what would you say would be the hardest repair you've ever had to conduct?
So I really should be more embarrassed about this story, but it's absolutely hilarious. So I'm gonna share it anyway. I'll set the stage. I'm testing some very old electromechanical relays with another tech, like vintage relays, with another technician. It's been a really long day. It's probably 10 or 10:30 at night at the end of a very long week. And I've just cracked open like my third monster of the day. And I decide I'm gonna pull a prank on my other tech. Like, yeah, this is what you do. You're playing around in the field.
Right.
So
gotta keep it interesting.
Some background. We're working on old electromechanical relays, very similar to this old Westinghouse. And to test them, you take them out of the gear. Oh, it's so heavy. You take it out of the gear and you test it like this on the bench, and then you put it back in the case. And you've got these, they're test switches. They're little disconnect switches, right? And so you put all these back in, and this connects like the CTs and the other circuits, the other stuff that integrates the relay scheme into the switchgear. And then this last test switch is the trip circuit. The red one is the trip circuit. So what we do, if we're on load, if we've got load flowing through the circuit, you'll take a meter and you'll check the voltage across this red switch before you close it in, just to make sure that like you didn't screw anything up. It's not holding a trip in, and then when you close this, you turn the lights off for thousands of people. Like that's the procedure.
Right.
Sorry, I've got notes for this story. So last circuit on the last relay of the last breaker that we're doing for this work. It's energized relay work. And my guy checks the voltage across the red switch. And I'm watching it from the other side of the substation. Checks the voltage, it's good, no issues. He pushes that test switch in, and as soon as it makes contact, I flip the lights off in the control house. And this dude panics. Fear sets in immediately. He thinks he just dropped a 35 kV like distribution circuit. Shut the lights off in the substation. He reaches in, grabs the whole relay, and just yeets it onto the floor. Oh, I laughed so hard I almost threw up. But after I'm like, oh, we don't have a spare for that. It's 10:30 at night. I gotta fix this before I can go home. So I'm out there.
Oh no.
I'm out there like with 3 tubes of super glue and a soldering iron, putting all these little plastic bits back together. We're getting this thing all wired back up. It's 4 a.m. before we retest it and get the thing pushed back in service. So yeah, that was definitely my worst repair. And it was 100% my fault. There's no excuse for that.
Right.
You want to play around with the guys. You want to, if you ain't having fun while you're at work, you're just working. But Jesus, that was
what's the
mistake.
point?
That was a mistake.
Exactly. My man just yeeted the whole freaking
just
relay.
Took the whole thing out, just threw it right on the floor. I'm like, why? Why is that your immediate response?
Why would you do that? But you can't even be mad at him because it's like it was your joke, you know? Yeah, 100%. Joel, jeez Louise. That's a good story. That's probably the best one I've heard of, like self-inflicted gunshot wound.
100% my fault.
So what time did you end up finishing? Like, how long did it take to get that thing put back together? Are we talking 6 hours, 4 hours? So were you there till like 3, 4 in the morning?
Yeah, it hit the ground. It probably about 10:30 at night. It hit the ground, and I At first, I was just in shock. So it was, a couple minutes of like, oh, let's run around. Maybe we have a spare. We've got a breaker that's not in service. I can steal one from. I call the shop, see if we got one at the shop. Nope.
Nothing.
So yeah, then it was hours of like, hey, super glue this little piece on, wait for it to set, and then solder this one little wire in, wait for it to set, put the next one on. Yeah. Trying to run to the hardware store. We found hardware at like Walmart at 1 a.m. and yeah, it was good. It was good. It was a good time. I eventually got out of there at 4 a.m. I just, to my knowledge,
you haven't played that junk since, have you?
Oh no. To my knowledge, that relay is still in service with super glue and wire from Walmart. And all this. Yeah.
Mercy.
Yep.
Well, I mean, if it's doing the job, it's doing the job, Now, with it being put back together like that, the question is, if he had to go do an ATS, an acceptance test on it, would it still pass?
If I looked at that and I didn't know the story, I'm like, hey, this is totally busted. I'm putting it on the report, at least. I'm going to tell some people, but 22-year-old me did not have that inclination.
That is some funny stuff. And I don't want to take up too much of your time today, so I'm going to get back into our next question if I can stop laughing at that one. Are you seeing a lot of retrofit modernization efforts to kind of upgrade and harden the grid? I know grid resiliency has been at the forefront in kind of dealing with all the new tech that's kind of, to increase load capacity on transmission lines and variable power feedback and all that. What are you kind of seeing in the industry from that aspect?
Yeah, absolutely. There's definitely a push from all directions to get a more resilient grid. A lot of that comes down to just getting more information out of the equipment that we already have. As we move towards like less centralized power generation with wind and solar, the transmission and distribution networks are getting vastly more and more complicated. So it's definitely a huge project to tackle from like the IT side. And then you have things like the Moore County substation attack that left like 40,000 people in the dark. That's really highlighted how vulnerable remote parts of our electrical infrastructure are. So yeah, there's a lot of work to be done, and a lot of work being done currently to both harden it from the the cybersecurity side, the IT side, as well as the actual physical security side. Obviously, it's impractical with a massive amount of equipment on our grid to armor up every transformer radiator. Like, that's never going to happen.
Right.
But to have better visibility of things, more cameras, real-time monitoring for what's actually going on, how load's flowing, where our weak points are, where our critical points are. Hey, maybe I've got this one distribution line in my system where if this goes down, like, we're going to have cascading effects and everything else goes down around it. It might be worth putting armor on that one transformer or something like that, or building redundancy there. And so we are seeing a lot of that. I'm definitely not an expert on how like NERC and FERC are responding with regulatory changes, but you can tell just on the projects that are being bid and the projects that are being sold, where the emphasis is. And a lot of it is, I would say, primarily on both the cybersecurity side and like the system protection and control side. But yeah, no, it's a complex nut to crack for sure, and a lot of time and a lot of money is being spent on upgrades and modernization.
Yeah, it is pretty wild. And I've read a couple of books surrounding this stuff. It seems like microgrids are kind of becoming more prevalent as well. Whether it's a homeowner with solar or, somebody selling their power back from a data center or something like that. I know Amazon just purchased a big nuclear power plant for one of their, AWS data centers. So are you seeing a lot more of the microgrids coming online? Kind of those, that you have to deal with I can't remember what they call it. The back power, I believe, is what it is, or the variability
right.
in load.
Yeah. So I mean, if you're a small fry, if you're a little green community, it's really difficult to get a power purchase agreement set up with your utilities, so that like, hey, if we have excess solar, I can sell back onto the grid. It's a difficult process because a lot of the infrastructure that we currently have it's not set up to have power flow back. There's a lot of concerns from like a safety standpoint. We don't want to be inadvertently overloading our transformers. Believe it or not, we still have tens of thousands of substations, tens of thousands of circuits that are still protected with relays that look like this. And that takes decades to fully retrofit. So what I have seen that I'm optimistic about is that a lot of the retrofits, a lot of the upgrades are being done with microgrids and small renewables in mind. We want to, you can never future proof it, but look into the future a little bit and say, hey, this spot is going to be good for wind and solar. I can design my substation with 10% more cost up front, save me a lot of work down the line. A lot of that is being done, and I'm definitely optimistic about how forward-looking the integrators are for things like that.
And I'm seeing it. I was just at a distribution station a couple of months back, and they were changing out all the electromechanical, going to solid state, and kind of doing things of that nature. So it definitely seems that way. But again, I'm not on the ground every day looking at things, so it's always good to pick you guys' brains on this kind of stuff. Now, we mentioned renewables and dealing with all those kind of things. What are some of the things that you think, in your opinion, that are the biggest issues facing renewables from having a more prevalent footprint, perhaps, than we're seeing now?
So while the government is trying to use taxpayer money to sort of tip the scale, when push comes to shove, it still needs to make financial sense to invest the massive amount of capital required to build utility scale wind and solar. Like $1 million here doesn't budge the needle. It's nothing in the grand scheme of things. So when you're competing with like the existing infrastructure, with nuclear, with coal, with natural gas, it's genuinely incredible to see as much renewable energy as we do, especially considering like most of these wind and solar sites are extremely remote. Like we don't have infrastructure there. So you've got to not only build the solar site, you have to build all of the infrastructure to collect that at the site. And then you've got to build more infrastructure to tie that into the grid somewhere on an existing transmission line, or build a new transmission line. Transmission lines, easily $1 million a mile. It's an absurd amount of money. So like there's just so much extra, blood, sweat, and muscle per kilowatt to get wind and solar on the grid than all of the other sources. Now, I'm optimistic with how far we've come, but I'm also, on the flip side, I'm also kind of bitter we don't see more of a push from the eco-friendly side to go nuclear. If it weren't for like all the red tape, nuclear would be, it would blow every other renewable out of the park. Dollar per kilowatt per pound of CO2, kilowatt per hour of human labor. Like it, not to totally derail your question, it's a really complicated market with more factors than anyone can keep track of, but it's really just, the cost. Wind and solar just need so much more material, steel structures, concrete, land, man hours, than any form of conventional power generation. I really, really wish there was more of a push for nuclear. It's clean. It's awesome. I've been to nuclear plants that are aging and on their third or fourth generation of control retrofits, and like it's amazing to just quantify like how much land of solar farm it would take to replace one reactor. So that's always been my opinion of it. But
now, do you follow SMRs at all?
No.
Do you follow the SMR space at all with TerraPower and NuScale and all those guys? Do you have an opinion on that?
I want it to work out. I really do.
I do too, so bad.
I'm not going to hold. That's not something I'm going to hold my breath on, dollars per donuts. It seems like a pretty good investment. But I know how things go. If you can get like the permitting and buy the land and do all the stuff, like just put a big honking nuclear power plant in the middle of nowhere and power the whole city and don't worry about it. SMRs are cool, but then you've got it more, distributed. You've got more of that more permitting headaches, more paperwork. I don't see it infiltrating the grid anywhere near as much as like small scale or commercial scale solar. So I'm not gonna hold my breath.
Like, no, I know, and I'm an advocate, and like you said, I think it's wild that the public perception of nuclear writ large is just like it conjures images of Homer Simpson with a vial of the, you know what I mean? It's crazy, and then if you're doing that, and just in general, like, I don't know, man. So I'm with you, and we've been running nuclear. Navy has been running aircraft carriers on smaller plants, submarines for decades and decades now. We have the technology there. It's just a matter of getting the consumer census or the public consensus centered up around it to make them understand. And I mean, the Fukushima reactor in Japan didn't do us any favors, as far as like the bleed back and all the other things we're dealing with. But I just saw a chart, I think yesterday, at deaths per power generation modality or whatever it is. Like, nuclear is literally the second from the bottom as far as deaths caused per operation type thing. It's insane.
Such a tiny percentage. I know. It's
so small.
You're preaching to the choir. I'm a huge
all right.
nuclear advocate. I've been to so many nuclear sites and never seen a Homer Simpson once. I mean, everyone there's
exactly
totally squared away
crazy.
because they have to, right? Like, there's a sense of duty to deal with this incredible. Yeah, it's dangerous, but it's also like one of the best sources of power. If we had fully invested in nuclear in the 70s and 80s, we would not be having a conversation about renewables right now, because everything would be clean running off nuclear. So hard to say.
And their carbon footprint is so minuscule compared to everything else. It's crazy. Right. I mean, if you look at what goes into it, like you said, even if you think about producing all the solar arrays to have them spread over this vast amount of land, well, it takes a lot of a carbon footprint to offset the production of those panels that are giving you your power now. Like, the lithium concerns, the cobalt concerns, and everything that come into it. It just seems like a smaller footprint with nuclear. So call me pro-nuclear, I guess. But that's kind of where I'm at with it as well, man. And that is probably one of the most heavily regulated, as it should be, because I know there can be, some serious fallout from that. But down to like the welds and the types and who can do their pressure vessels and all that. Like, they have to be like the metallurgy and stuff that they source with has to be approved by the NERC, like it's crazy the amount down to the welds and everything else, like I said. So highly regulated. And I just wish more people would get on board with that. And now you're not dealing with all the additional transmission lines because you had to place your solar arrays out in the middle of, BFE nowhere. And now we got to wheel them through. So now I've got transmission towers in my backyard. Nobody wants that either. And I think you could get away with a lot of that and be able to put the nuclear where it needs to go. So
it should be, I'm with you. More centralized. Yeah. Better planned out. Preach to the choir.
But we're just two dudes having a conversation. So I don't know if that's going to, I doubt it has any impact on anything whatsoever, but I'm glad it's always good to talk to other people that realize, I think most people in power do realize the value of nuclear.
Oh, for sure.
You know what I mean? It's just mainly the public consensus that really gets us to where we are,
Thanks,
not
Karen.
Realizing that you need those transmission lines. Yeah. Power Karens. Like the next, like you want solar, but you don't want me to put the transmission lines going through your property over here because now it's an eyesore. Well, you can't have both. You know what I mean? So it's just insanity. So that was definitely a segue off of our question set. But like I said, that's what I meant to ask about, and I didn't. So nuclear is definitely one of those things, and it's always good to get everyone's opinion on that. But kind of getting back to it, do you ever wish you had chosen a career outside of power? Did you have different aspirations in life? What kind of drove you into this space?
Do I ever wish I had a career outside of power? No, absolutely not. At this point, like the only thing I get is maybe a tiny pang of regret every now and then that I didn't go to college and get a bachelor's degree. Like I said, I went to tech school. At the end of the day, yeah, I went to school for a year and a half, and I had to work my ass off through my 20s to kind of climb my way up the ladder and to learn things. But I learned some absolutely crazy skills. I had incredible opportunities. I got to work at a startup that was really massively successful.
That's awesome.
And now I have like a corporate sales job making well more than double what most of the college grads I know make. I don't regret it for a minute. When I was in high school, I wanted to be a journalist. I'm really glad that didn't pan out. This is way cooler. This is so much more fun. Yeah, so I'm gonna retire from testing, or from the power industry at least, and I have no problem with that at all.
Well, and what's crazy is a lot of people don't realize, even the folks that go to the 4-year traditional, engineering schools, a lot of them end up in NETA anyway. You just, you don't have your PE stamp perhaps, or even,
right.
I'm getting ready. I think we talked about Bibic before. I'm getting ready to do an interview with Bibic. Bibic's a full-blown PE, you know what I mean? And still is out doing field service work and testing after all those years of education. And now y'all are the equivalent in the space.
Well, I know
you know
the
what
same
I mean?
place,
as far as it goes.
So.
Yeah, I mean, you may not be able to put the stamp on it, but I mean, like, okay.
That's what the nerds in the office are for, right?
Absolutely. So,
no,
and dude,
really
I
cool
hear
because...
that. That's kind of one of those things that resonates too, as well, is like people are like, well, I didn't get the 4-year degree. It doesn't, like, I mean, and this is getting more like, in talking about today's education system and things like that. I just don't think it's as relevant or prevalent as it used to be, because the ROI is not as high based on what I'm seeing. I would much rather have someone who did a 2-year vocational tech program in power, goes out, gets OJT, and I actually just made a post on this from the video I did with Adam. You are literally going to end up in the same end state with no debt. You're getting on the job training. Same thing with the electricians or plumbers or boiler makers or whatever. Like the IBEW has a JATC program. These guys are getting paid to go to school, go out, implement the training and education they're getting, and then moving forward and collecting the wisdom that comes along with it and everything else. So to me, and that's, again, a big push for us from the content piece, is come find a position here. You're going to have to go out. You're going to have to cut your teeth. You're going to have to do the grunt work. You may end up on top of a transformer. You may be the tool hauler for a little bit. But if you cut your teeth there, you're still getting a paycheck. You're not getting further in debt, and you're increasing those skills. And now you have a career. I mean, some of these guys with OT are making $200K a year. It's crazy.
Yeah.
Getting out and hustling, especially at the NETA 4 rates and things like that. It's absolutely insane. So awesome to know that you wouldn't have changed it up. And I'm glad you didn't become a journalist. Nothing wrong with journalists, but it
wouldn't have worked out for me. I can tell you that.
So, no, you don't think so?
No, but it's really interesting because you have this crazy pool of talent. It really doesn't matter where you came from. I've got mechanics, like auto mechanics, that are the absolute best techs in the world, and I'm like, okay, you're maxing out your performance review. I got to get you a raise. I got to get you moved up as soon as you're ready to take your NETA 2. As soon as you're ready to take your NETA 3, take those tests, move up the ladder. Like, you're amazing. And then the flip side, like, I've had guys come out of bachelor's programs, and then they get stuck in the field because company needs substation guys, right? So they I'm just gonna come help out, and they don't know how to turn a wrench. And I'm like, you're useless to me. Like, I don't care how smart you are. I don't care that you know how to design this. If you can't tell me what I need you to go short the CT circuits out of the breaker. What does that mean?
Right.
You're not helpful. So
you can design, but you can't go. No, and this is not for the audience, not a shot at PEs or anything like that. Not. It's just a different skill set, I think, more than anything. Exactly. You know what I mean? Because they don't have the exposure, like you said. They haven't done the groundwork to get in there and read the effing manual, right, and do the things and gain the wisdom and experience. And like I did the 4-year EPTE program. It's like the kind of like the hodgepodge between the 2-year and the full blown PE program. And like I couldn't have told you all the functionality from one relay to the next. Like, it's just one of those things. That's not what the school system's about. It's about teaching the theory, the physics, the fundamentals, the math, the formulas, and things like that.
Right.
And so again, it just takes the efforts on ground to make that kind of stuff happen and get better at it.
Right. Just to be 100% clear, if you're a professional engineer, I want you to have gone to engineering school. If you're a doctor, if you're going to do surgery on me, I want you to have gone to med school.
Medical school is
the school to be in the power industry is to turn wrenches and be in the power industry. If you're going to be a transformer tech, you don't need a 4-year degree or a 6-year degree. You don't need to go to med school. I need you to learn how to do your job and get good at it. And a big part of like what I'm doing on YouTube, and a big part of like what I'm trying to do, or what I've tried to do in the past with my, with my teams, is like, okay, you've got this base of knowledge. How do we expand that so that you can be a better, well-rounded tech in other aspects? How can we move you up the ladder, get you more money, get you more skills? And at least in this line of work, none of that requires school. School is in the field. School is turning a wrench. School is taking stuff apart, putting it back together. It's testing it. It's, hey, this megared bad. Well, what can we do to fix it? Things like that. It's talking to guys. So
absolutely,
it's just
not only that, but if
totally
you think about it from the NETA aspect, they're still going to have to go out and get the education and do the studying to make sure that they're proficient in all the other things that are required to upscale your skills and actually get those next levels, which in turn result in higher pay, more responsibility, more training, and things like that. So there's still definitely that continuum of education that has to take place, in my opinion. That is a balance. So I think you're spot on with that, man.
Yeah, I definitely.
Now, looking at, sorry, go ahead.
No, I was done. Go for it.
Oh, now looking at give us Joel's outlook on the power, the power industry writ large. All the retrofits and all that. How are we looking for work for the next decade, 2 decades? Is it going to slow down? Is it going to keep going? What's your opinion?
So from what I've seen in the conversations I've had, everything in the industry is kind of cyclical. So like a period of massive growth and massive investment. It'll taper off and then it'll be quiet for a little bit, but it's not done. Like, hold your breath. We're not done. It'll all pick back up again. So even if like the couple projects that you've worked on, like a couple big investment things we've seen, if those peter out and they finish up and we hand in the report and you don't have anything on the horizon, it's going to come back. So I will say I've personally have transitioned out of like the transmission and distribution world, but I can tell you I'm very bullish on the data center market. The pandemic didn't slow them down at all, right? It just put your mask on and get that server rack back up. Like it never stopped at all. It just seems to keep going up and up and up. Data halls are getting built out, new construction starting. I will say the equipment procurement side is getting slightly easier, but I wouldn't pin that on like the market slowing down. It just seems that production is ramping up and is able to keep up
a little bit to meet need.
And to meet the demand, and they wouldn't ramp up like that if the demand wasn't going to be there in 5 years. So I'm pretty optimistic about it.
Awesome. Now, this is one that's usually contentious for folks, and I still like to ask the question because AI seems to be the buzz for everybody these days. Do you think that's going to have any impacts on technicians or companies moving forward?
I don't know. It is such a buzzword, right? But there's definitely some applications to be optimistic about. There are opportunities to use AI to make better training materials or better like building design tools. I've heard of one application where you can use sort of AI and large data models to optimize like grid scale power availability. Like, hey, when do we need to spin up this turbine? When do we need to spin it down? How much solar is going to be available? Even like weather modeling and things like that. AI can do better than people can. So I'll say I'm optimistic about it, but on the other side, like nothing is going to come out in the next year or 2 or 3 that's really going to revolutionize the technician's role. Maybe I'm wrong. Maybe all relay testing is going to be done by AI at some point in 2 years, right? But I highly doubt it. Like you're still going to need an engineer to actually like sit down, look at the prints, figure out what needs to be done. You're still going to need a blue collar guy to go out and maintain everything. You're still going to need somebody to rack the breakers in and close them. You're still going to need a lineman to come out and close the cutouts. Like none of that stuff is really going to dramatically change. At most, our jobs are going to be a little bit easier. Parsing through emails is going to be easier. Getting people mobilized to a job site might be a little more streamlined with some AI tools and scheduling and things like that. But I don't think anything is going to be necessarily like turned on its head, at least from a technician's perspective.
Makes sense to me, and that's kind of one of those conversations I had with Adam on that last interview, because I like to ask the AI question, and that's one of those things that kind of does come to light. Is it could hurt the knowledge in the technicians, and I don't see a pathway ahead for that to be integrated into the actual test equipment, like you said, for extrapolation of data sets and things like that. Larger model data models and things like that. Perhaps I could see it having a lot more of a play. And one thing I did kind of see the other day, and it's not really AI, it's more VR and kind of like a simulated environment, but a lot of it comes up with like AI being injected in to like introduce scenarios for technicians to do like virtual training of relays and things like that. So maybe there's a pathway there, but I'm kind of with you. I hope it doesn't get into the test equipment, or at least that's my humble opinion. So Joel, if you could go back 10 years ago to young Joel as a technician, is there any advice that you would give yourself?
Buy more Bitcoin.
No, that would have been the answer right there. No, I would agree with that.
On a serious note, I got really, really lucky when I started out in the industry, just regardless of many a terrible decision on my part. I got super, super lucky. I got hooked up with a great company. I got hooked up with great people. One thing that's paid way more dividends than my timely departure from crypto has been investing in my network of people, making good friends in the industry, people that you can call with problems. We talked about this earlier. People that call you with problems. Your Rolodex is worth its absolute weight in gold. Sometimes it doesn't necessarily feel like you'll ever need to cross a bridge again. So like you burn it when you leave a company. But those have been some of the biggest mistakes that I've made. Have been not leaving companies. Sometimes it's always a good thing. Most of the time it's a good thing. In my case, I've been shooting about 70%. It's been a good choice when I jump companies, but you got to do it in the right way. When you screw up, look somebody in the eye, shake their hand, apologize, really keep those connections strong. It's been way, way, way more valuable to even somebody that you don't necessarily get along with. I don't like working with you in the field. I want to have a good working professional relationship with you. I'm incredibly grateful for everybody on my speed dial, more than anything else in the world. So yeah, advice for 19-year-old me, first year in the industry, I'd have to say just invest more time in people and really try to keep emotions out of the workplace as much as possible to keep those professional relationships as strong as possible. Because it's so much more valuable than the job that you have now. It's so much more valuable than any tool in your truck. Like other people are the only reason anyone succeeds at anything nowadays. So that's my advice.
Right. Well, and it's kind of corny, right? They always say your network is your net worth and that kind of thing. Right. And I agree with it. Like it's literally the ability to go out and it applies. It's universal in its application. It applies to me in the recruiting world as well, just like it does in the testing. I mean, we're wired to be tribal people, and have community and things like that. So, and really putting a lot of value on those relationships. I couldn't agree with you more on that aspect of things. And but as far as the Bitcoin, man, I'm one of those that got wiped with crypto. So yeah. SEC got me scared there for a little while with regulations and things. So I ended up I was not I wasn't hodling as I should be, I guess. But well, that's pretty much that runs through our questions for the day, man. And I've thoroughly enjoyed it. I think people are going to get tons of value out of this. How can people get in touch with you? You're definitely one of those that definitely doesn't mind sharing, obviously, through your videos with Testing Tech Tips. And again, a quick plug for Joel's channel, Testing Tech Tips. Phenomenal. All the stuff that we've kind of talked through with relays and breakers and multi case breakers and time delay curves and everything else Joel's already doing and is always putting out more content. So please go look up Testing Tech Tips on YouTube. I'll also throw a link in the description of the videos. As always, we release these things as little digestible 3 to 5 minute clips throughout as well. So I'll make sure that we tag your YouTube channel in there as well. But do you have any parting thoughts for the audience? Oh, my pleasure, dude. Like I said, anything I can do to advance awareness in the industry is super important to me. But where can folks find you? And do you have any final parting thoughts?
Yeah, it's testing tech tips at youtube.com. I'm not really spun up on all the other socials yet, but I'm working on it. We'll get there. LinkedIn, honestly, I've got more followers on LinkedIn than I do anywhere else. But no, we're definitely working on that. Check it out, testing tech tips at YouTube. And yeah, no, thank you so much for having me on. For everyone out there watching, just stay safe, stay humble, keep your nose to the grindstone, and things work out.
Awesome, man. And like I said, it was a fantastic time. Thank you for taking time out of your weekend to hop on and have a conversation with a random recruiter guy. Like I said, I do have a passion for this stuff. Thoroughly enjoy it. And again, thoroughly enjoy your content. Thanks for sharing. And with that being said, hope you all have a fantastic one. Until the next time, Mike out.
Thanks, man.